In Alice in Wonderland, the Red Queen says, "Why, sometimes I've believed as many as 6 impossible things before breakfast." This quote describes how I'm feeling today. This episode is coming to you after a morning of frantically learning all I could about the new Perseverance rover's findings of possible signs of ancient life on Mars. I have not showered. I have not put on makeup. I may still be wearing pajama pants. We're here to bring you science, and getting news out the door has taken priority. We're not going to do a deep dive into these results in this episode. I've posted a short, and I'm going to summarize things here in our intro. Full coverage is coming to you in a second video I'll record tonight or tomorrow. Allie and I are splitting the editing. I have no idea which video you will get first. All right, here is what we know. On July 18th, 2024, the Perseverance rover took an image of a rock nicknamed Shavia Falls. This rock is located on the edge of an ancient, now dry river that flowed through Jezero crater. The sedimentary rock in this region is made of fine grained materials, and this is the kind of rock you look for when you look for preserved materials from the ancient past. The adjoining conglomerate rock includes nuggets of the mineral olivine, which is known to form in water. The fine grained sedimentary rock has a patterned surface that looks like faded leopard spots. When viewed with a spectral imager, the tan background rock is your standard iron rich mineral that we see everywhere on Mars. Using a spectrograph and narrow band imager, researchers find that the spots uh, they appear to have iron phosphorus minerals surrounding iron sulfur cores, and the rock is rich in organic molecules. Researchers pushed Percy to the limits of his abilities. And as best the rover can tell, this rock is consistent with ancient microbes living within river sediments. While these kinds of minerals can be formed through chemical processes, it requires heating, and Percy doesn't see evidence that these rocks experienced that kind of a process. Ultimately, we can't say with certainty that this rock contained life without studying it in a more powerful laboratory. And Mars doesn't have the needed equipment, and we don't have the needed Mars sample return mission to bring this rock home. So, yeah, we're not saying it's fossilized alien microbes, but we're not saying it's fossilized alien microbes. More on this in our special breaking news episode. In this episode, we're going to look at Mars' lumpy interior, an exoplanet forming around a sun like star, and new data on interstellar comet 3I Atlas. As promised, we also take a closer look at the case of a massive blue star that made the terrible mistake of eating its black hole companion and ended up going supernova. We also have the latest news from the launch pad. I am Dr. Pamela Gay, a senior scientist at the Planetary Science Institute, and you are watching Escape Velocity Space News, an independent science news show funded by you, our donors, through Patreon. 2 years ago, we ran a story on how high resolution seismic data was used to map out ancient mountains that still exist, like something from a Godzilla movie, 3,000 kilometers beneath the Earth's surface. These ubiquitous structures were thought to be ancient ocean seafloors that haven't yet melted and now exist to perplex geologists. I think about those mountains a lot. The echoes of what once was keep finding their way into how we see our world and our universe today. And even though we don't have the same network of seismographs for Mars, it turns out the data captured by the InSight lander was good enough to measure a super lumpy internal structure in the red planet. Having a lumpy interior doesn't make these worlds the same. I too have a lumpy internal structure, and I'm pretty sure the science behind my small intestine structure is in no way related to any of Earth's geophysical processes. And it turns out that Mars' lumpy insides also have a unique origin story. Mars doesn't have plate tectonics like Earth. Its surface features don't get recycled over the eons, and its volcanoes don't mark plate boundaries. Instead, its surface is shaped by the steady impact of asteroids and comets. Early in our solar system's history, large impactors were more common, and it now appears that the age of heavy bombardment pounded fragments of rock, fragments as much as 2.5 miles or 4 kilometers across, deep into Mars' mantle. The InSight lander was able to map these structures using seismic waves generated by Mars' rare quakes and the occasional impact of a meteor. The density of these ancient impactors isn't the same as that of the surrounding rock, and seismic waves changed velocity as they passed from Mars' mantle rock to the fragments of ancient impactors and back again. There is a certain poetry in this. We can't see those ancient impacts when we look down on Mars with our spacecraft. We don't see them as we rove Mars' surface with our many wheeled scientific explorers. We only see these fragments of ancient impactors when Mars shakes. And that happens when modern impactors strike Mars' surface. These results appear in a pair of papers in the journals Science and Nature that are led respectively by Constantinos Charalambous and Heising Bai. Our current global ensemble of telescopes makes it possible for us to see details hidden from prior generations. As more and more of the sky is observed at the highest possible resolutions, there is hope we will catch other solar systems at every stage of development. This allows us to understand the diversity of ways planets form and evolve. The sky is large, and even though we know where star forming locations are in the sky, it still will take time for us to observe system after system and see what there is to see. But we're getting there. Newly published images taken with the European Southern Observatory's 8.2-meter Very Large Telescope in Chile looks at a 5 million-year-old baby sun-sized star just 433 light years away. At this distance, using the Large Telescope system, astronomers are able to resolve details in the solar system's disk and, remarkably, the motion of a roughly 5 Jupiter mass planet. 4 sets of observations were taken between October 2023 and April 2025 using a coronagraphic mask to block out the young star's light, allowing the faint disk to pop into focus. While 2 years of data may seem like a lot, this world is roughly twice as far from its star as Neptune is from our sun, and it's moving super slowly. Motion is detectable, but it's not something you'd notice with a quick look at the data using your eyes. Luckily, we do have computers. And remarkably, the motions we're seeing, the way the planetary disk has gaps, and all the variations in dust, everything, it fits with what we expect. This system confirms that we are starting to be able to model how forming star systems should behave. And that is new and kind of awesome. This work appears in a pair of papers in the astrophysical journal Letters, led by Rachel van Kapelseen and Laird Close. Before we go to break, I'd like to check in on interstellar visitor 3I Atlas. This high velocity comet is hurtling at 130 miles per hour toward the inner solar system. As things heat up, new images from the Gemini Observatory show the growth of a tail and visually looks just as we'd expect from a comet. It's in the details that this object stands out. Archival images from the TESS mission show that 3I Atlas was already active 6 astronomical units from the sun. While our solar system's native icy centaurs have sometimes been shown to be active at this distance, it's rare. The Sphere X and JWST observations have also shown that 3I Atlas has the highest carbon dioxide to water ratio ever seen. This could mean it formed in a different place in its solar system than the comets we're used to. Or its solar system or history have shaped it into something unique to us. Pretty much any telescope that can observe 3I Atlas is observing 3I Atlas as it heads towards Mars orbit. In the coming months, we will lose it behind the sun, but we'll get another view come December as it heads back out of our solar system. After the break, we'll be back with a closer look at a massive star that tried to eat a black hole and had supernova-sized regrets. Stay tuned. Last week, I highlighted supernova 2023 ZXD. This weirdo explosion was found in Zwicky transient facility data obtained on July 7th, 2023. It would take 195 days for this data to go from fresh observations to a Slack bot alert. And along the way, it would get passed from the light curve anomaly identification and similarity search tool to the integrated young supernova experiment. Regrettably, this was just one of millions of alerts the 48-inch telescope puts out every night as it scans the northern sky for things that flicker and flare. And processing all those alerts isn't a fast process. And at the time, it looked like a regular Type 2 supernova from a regular massive star. It would take a combination of both additional observations and a deep dive through archival data to figure out just how weird this event actually was. On March 17th, 2024, a classification spectra was obtained by the Magellan Low Dispersion Survey Spectrograph 3, and the event was classified as a Type 2N supernova, which means this was an exploding massive star that had a shock that interacted with a rotating cloud of hydrogen that was ionized by the supernova ejecta. This can happen when a massive star sheds large amounts of gas that its supernova ejecta crashes into when the star dies. Further observations in July of last year turned up helium lines, and the explosion was yet again reclassified, this time as a Type 1Bn supernova, which is the result of a massive star with helium crashing into the surrounding hydrogen as it explodes. But there's more. The team, which was led by principal investigator Alex Gagliona, used archival data to look for long-term changes in the star's brightness and the supernova's evolution. This data spanned from nearly 8 years prior to the explosion to 256 days after the explosion. And when I say they used archival data, I mean they grabbed data from every possible telescope network and data archive, including Atlas, Pan-STARRS, ZTF, Las Cambres Observatory, Swift Observatory, and more. In addition to the scavenger hunt of data, they also took new spectra using some of the world's largest telescopes, including the Multi-Mirror Telescope, Magellan, the Nordic Optical Telescope, and Gemini North. With more photons captured in more ways than you can shake a stick at, they could reliably state the following. This supernova took place in a system where we wouldn't really expect a Type 2N supernova. Specifically, it occurred in a smaller galaxy with negligible star formation. 4 years prior to going supernova, the star began to slowly brighten. And in the last 400 days before the explosion, the rate of brightening increased. Following a normal peak in brightness, the star faded and then weirdly re-brightened 224 days later before finally rapidly dimming over just 60 days. The research paper on this discovery, which appears in Astrophysical Journal, is a masterclass in comparing data to every possible common cause before realizing an uncommon cause has to be at play. The early observations tell the story of a massive blue giant star, more than 30 solar masses in size when it was born, that has runaway mass transfer of increasing luminosity spanning years. This, to paraphrase the paper, naturally explains the presence of a hydrogen rich torus of material and a helium rich polar outflow that could be seen in post supernova spectra. This also explains the double brightening. As the press release from the Harvard Smithsonian Center for Astrophysics explains, the early brightening came from the supernova's blast wave hitting low density gas. The second delayed peak was caused by a slower but sustained collision with a thick disk like cloud. The structure and the star's erratic pre explosion behavior suggest that the dying star was under extreme gravitational stress, likely from a nearby compact companion, such as a black hole. From theoretical modeling, they find the system is well matched to a merger driven explosion between an approximately 10 solar mass black hole and the dying helium core of what was once a 30 solar mass young star. This is truly a system of giants. To get a 10 solar mass black hole orbiting a dying 30 solar mass star, you need to form a system that started out with that 30 solar mass star and had an even bigger star that died first to become that 10 solar mass black hole. Over time, the orbits of the two objects decayed until one day, our giant blue star found a black hole in its outer atmosphere, and things quickly went terribly, terribly wrong. Are researchers 100% sure this is what happened? No. This could just be a weirdo luminous blue variable with a Wolf-Rayet past that decided July 7, 2023 would be the time of its demise. While this solution makes it hard to understand both the initial and secondary brightening, it's not impossible. And while the precursor data does seem to fit that kind of a story, it turns out stars sometimes behave in ways we didn't expect. But based on everything we know, it really looks like a blue giant star that started out with 30 solar masses material or so, expanded out, went through mass loss, had a decaying orbit, and ultimately made the mistake of eating a black hole. The moral of the story is this: when randomly reaching out to grab a handful of food, make sure you know what it is you're about to stick in your face or your gravity well. Up next, we look at this week's Tales from the Launchpad. Stay tuned. Without further ado, here is this week's Tales from the Launchpad. On August 23rd, Rocket Lab launched the Live Laugh launch mission from their New Zealand spaceport. Let's watch the launch.
5, 4, 3, 2, 1. Liftoff.
Beginning pitch 1.
The mission was conducted for a confidential commercial customer and placed 5 satellites into orbit. No other details were announced. On August 24th, SpaceX launched the CRS 33 mission to the ISS from Launch Complex 39A. Let's watch the launch.
5, 4, 3, 2, 1, ignition, and liftoff. Go Falcon, go Dragon.
And liftoff. NASA's SpaceX's 33rd Commercial Resupply Services mission is on its way to the International Space Station.
New for this mission was a propulsion system in the trunk called the boost trunk, which carried 2 independent Draco thrusters and their own propellant tanks to reboost the ISS's altitude. Because of this capability, CRS 33 will spend several months longer at the ISS than previous Cargo Dragon missions, returning in December. The capsule carried 2.3 metric tons of supplies in the pressurized capsule, in addition to the propulsion system in the trunk. On September 2nd, Israel launched the Athik 19 satellite into orbit on a Shevet 2 rocket. No further information about the satellite was announced, but Athik is known to be a series of intelligence satellites for the Israeli military. On September 4th, China launched the Shiyan 29 satellite into orbit from the Xizang spaceport. Let's watch the launch. No information was provided about the satellite or its orbit. The Shiyan series of satellites has been used in the past to develop technology for future Chinese military launches. Your mega constellation update this episode is: SpaceX conducted 8 launches of Starlink satellites, and China launched the 10th batch of Satnik LEO satellites on a Long March 8 rocket. We keep track of orbital launches by launch site, also called spaceport. According to rocketlaunch.live, so far this year, the United States has had 122 launches, China has had 53 launches, New Zealand has had 12 launches, Russia has had 7 launches, French Guiana, Kazakhstan each have had 4 launches, India has had 3 launches, Japan has had 2 launches, Austria, Israel, Norway each have had 1 launch. This makes the total number of launches so far this year 210. There have been 9 failures, reminding us space is hard. Finally, there are 9 toilets in space. Before we go, I wanted to ask, where are you going to be on April 13th, 2029? That's the day the asteroid Apophis will pass within 19,600 miles of Earth. At this distance, humanity is entirely safe. But no one would be surprised if this 450-meter across space rock took out more than a few satellites as it passes in and out of the orbits of geosynchronous satellites. To celebrate this potentially satellite-eating asteroid, the United Nations has declared 2029 the year of the asteroid. The European and Japanese space agencies, ESA and JAXA, are planning to run down Apophis with the still under development mission Ramses. And if budget cuts allow it to survive, the repurposed OSIRIS-REx mission will transform into OSIRIS-APEX and take data for NASA and our partners. I have no idea where I'll be, but I have one offer of a usefully placed couch I may crash on. This flyby will be best seen from Europe, Africa, the Middle East, and Western Asia. Folks in the Americas, we're going to need to travel. Coming late to the asteroid party is asteroid 2024 YR4. This smaller 60-meter across space rock has all eyes ready to watch it and its close approach to the moon. Current data puts 4% odds of YR4 hitting the moon and potentially causing a meteor shower. This weekend, in a new series we're calling That Takes Math, I'm going to run the numbers on just how much lava at how high a temperature there would need to be created in this kind of an impact or past impacts for us to see melted rock on the moon from our position on Earth. Check out our YouTube channel to catch this thoroughly silly upcoming show. And that's it for now. Good night, everyone. And remember to go out and look up. Oh, and please also give this video a like and subscribe so the algorithm tells you and the world when new science is ready to be learned. Bye-bye.